All right, same idea here. We're going to use this elimination method, but I notice with this system of equations, there's a little bit of an issue because I don't have the same coefficient for either the x or the y. So I'm going to do a little bit of work here. Well, one thing that I notice is the coefficients of the y's are 15 and -3. If only they were the same number with different signs, then I could just add those two equations together, and this would be a piece of cake. Well, I could get them to be the same number if I multiplied this equation by 5. So this elimination method, we want to keep in mind we can do whatever we want to these equations as long as we do the same thing to both sides, right? I'm keeping that equation balanced by multiplying both sides of the equation by the same number. If I multiply the second equation by 5, I get 5x minus 15y equals 100. And the other equation is still the same, 7x plus 15y equals 32. And now I can do what I did in the last slide. I can add these together, right? Minus 15y plus 15y, those go away. 12x equals 132. Do you know your 12s tables? Divide by that 12, I get x equals 11. That was easy, right? I love doing these problems. I love this time of year because I get to say to students, do whatever you want. If you wanted to graph these, go right ahead. If you wanted to isolate one of those variables and use substitution, go for it. If you want to multiply or divide equations by anything, go right ahead. You can do whatever you want as long as your arithmetic's good. You are in charge of these equations. The equations aren't in charge of you. You are the boss here. Do whatever you want. We get a nice answer. Remembering again, we want to substitute back in and solve for the value of y. Maybe I'll substitute into the second equation this time. So 11 minus 3y equals 20. Subtracting the 11 gives me negative 3y equals 9. So y would equal negative 3. So easy, right? Multiply, divide, piece of cake. Another example, same idea, right? I'm inspecting these. Again, I could graph them if I wanted to. I could use substitution if I want to, but this is set up for elimination, except I don't have the common coefficient with any of these values of the x and y. But I notice I have an 88 and a -8. Okay, I can get to 88 and -8 to have the same coefficient. What if I multiply the second equation through by 11? Now, when I multiply this time, I'm just going to write it up above, just so I don't have to rewrite that 88 line. So I have negative 88x plus 33y equals, remember when you're doing this, multiply the other value as well, so equals minus 11. Just be careful. Make sure you multiply both sides of the equation. All right, so I can kind of forget that that was ever there. And now add those two together. So minus 88 plus 88 is 0. 33y minus 5y is 28y. Minus 11 plus 39 is, oh, look at that, 28. Piece of cake. Divide by my 28. Divide by 28, and I get y equals 1. That was easy. Remembering now I have to go back and substitute in for y to solve for x. So in order to do that, the question comes up, which equation should I use? Should I use this one, or the one I just came up with, or the original one? Whichever one, there's 3 equations up there now, whichever one looks best for you. Doesn't matter. I'm actually going to use the original one with the 8 because the numbers are smaller. So minus 8x plus 3 times 1 is 3 equals negative 1 minus 3 minus 3. Now watch here, that gives me 8y equals negative 4. My answer is not 2. Follow through on the arithmetic, on the algebra. I'm dividing both sides by the coefficient of y. That's 4 over 8, not 8 over 4. So y will equal positive 1/2. Nope, I did that wrong. Sorry, that is an x. X will equal positive 1/2. So my ordered pair again would be 1/2, comma 1. Right, so just a easy way to do these problems. Just find a common coefficient. Piece of cake, we got this.